Over the years, we've had numerous different pulse width modulation ECM motors. We've had the variable speed constant torque, VCT, the multi-speed constant torque, MCT, the variable speed constant air, VCA, and the fixed speed constant torque, FCT. There are troubleshooting guides that are available for all of these motors, because when you're troubleshooting the ECM motor, you need to know what kind of voltage you're going to see on the communication lines to the motors. This video is going to cover troubleshooting the new ECM motors that you will find on the NFC furnaces and air handlers put out by Carrier and Bryant. The first thing to recognize about ECM motors is that all ECM motors have line voltage always applied to the motor. There'll be usually 3 wires, the line, the common, and the ground, that supply 115 volts or 208/230 to the motor. You will need to first verify the correct wire location for the line voltage. Normally black is 115 volts. White is neutral and green and yellow is ground. This can vary between the 115 volt and the 208/230. So verify with the motor data that you have for your particular motor. The other thing you want to verify is your low voltage. And on the new NFC furnaces and fan coils, the brown wire feeds a constant 15 volts DC to the motor. The yellow wire feeds back, completing the circuit from the motor to the furnace control, and the orange wire is the RPM feedback to the control board. You want to check for secondary voltage on the control board, and you want to manually close the blower door switch and verify that you have 24 volts AC between R and C at the thermostat terminals of the furnace control. The pulse width modulating blower motor used in the current furnaces is controlled by the on-off switching of the DC voltage circuit and resultant current through the motor controller. All of the tests that we're going to talk about in the next few slides will be between the brown, yellow, and orange wire and the common terminal on this thermostat strip. As we said, there are 3 wires that control the motor. The brown wire is the 15 volts DC to the motor at all times. The yellow wire is the motor torque control, and the orange wire is the RPM feedback from the motor to the control board. So next we want to check the 15 volts DC power to the blower on the brown wire. Verify that all harnesses are connected between the control board and the motor, and the 115 volt power is on. Close the blower door switch. Set the meter to volts DC, VDC. Insert the plus side meter probe into the back of the brown lead at PL16. Touch the negative meter probe, to the common on the furnace control board. Voltage from the furnace control should be about 15 volts DC at the brown wire. Note, a reading of approximately 35 volts or higher will indicate the green ground wire on the motor is disconnected. Repair as needed. So when testing the brown wire, you should see 15 volts DC to the motor at all times when the furnace is powered. Next, we're going to check the motor torque control signal on the yellow wire. Our power should be on. There should be no call at the thermostat terminals. Close the blower door switch. With the meter set to volts DC, insert the plus meter probe into the back of the yellow lead of PL16. Touch the other negative meter probe to common on the furnace control board. With no motor operation, the voltage will be 10 to 15 volts DC. Actual voltage will depend on the meter being used and the manufacturer of the motor. So when testing the yellow wire, as we said, there's going to be 10 to 15 volts when there is no fan being called. When the furnace is running in low fan, you will see approximately 12 to 13 volts DC, and when the motor is running at high fan, you will see 4 to 5 volts DC. So you will note that the torque control will decrease the faster that the motor is operating. So the voltage will remain constant on the yellow lead of PL16 until the component self-test starts the main blower. After approximately 25 seconds and after the hot surface igniter turns off, the blower will start and the voltage on PL16 will start dropping. Nominal voltage on the yellow lead of PL16 decreases to approximately half of the previous measured voltage. Voltage is stable until the blower shuts down. Voltage will return to 10 to 15 volts DC when the blower shuts off. If the DC voltage measured on the yellow wire changes values as outlined, the furnace control is creating the proper switching and is operating properly, and the harness is intact. Motor replacement is indicated. So now let's check the motor RPM feedback signal on the orange wire. You will be measuring AC voltage between the blower harness orange wire and the 24-volt common terminal on the control board. Measured voltage will increase as the motor spins faster. So at 0 RPM, you should have 0 volts. At 1100 RPM, you should have 3.0 volts. This is used in the performance and preferred models as an on-off indicator of blower operation. It's used in the Infinity and Evolution models as an RPM feedback loop to control the motor speed for constant airflow output. As always, when making these checks on the motor plugs, you should use the skinny test probes so you don't damage any of the wires or the plug connections.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.